Let's look at our second video. Okay, we're going to skip the example where find dy over dx where x is equal to 1. We're going to go to the next example. Find all values of x at which the tangent line to the curve y is equal to x squared minus 4 over x plus 3 is horizontal. Alright, so what does that mean? There's some kind of curve, y is equal to that stuff, okay? Just any old curve, okay? Think of any old curve. What am I looking for if I'm looking for where the tangent line is horizontal? I'm looking for where my tangent line has a slope of 0, right? So in other words, what I need to do is find the slope of my tangent line here and find out where it's equal to 0. Or find the slope of my tangent line, set it equal to 0. So what's the slope of my tangent line known as? The derivative, right? Alright, so what I'm going to do is I'm going to use some notation like dy over dx, or maybe I'll use y prime just because we haven't used that much yet. Y prime. How am I going to find the derivative here with respect to x? I'm going to use the quotient rule. Low d high. Low d high. Minus I. D low. All over low squared. All right, let's actually go through and take this derivative. We have x plus 3. Derivative of this part is what? 2x minus, drop down, x squared minus 4 times derivative of that's 1 all over x plus 3 quantity squared. Well, what will that be? That'll be y prime is equal to 2x squared plus 6x minus x squared plus 4 all over x plus 3 squared. Or we could say y prime is equal to x squared plus 6x plus 4 all over x plus 3 squared. Check my camera again. I don't have a tripod, so it moves sometimes when I hit record. Okay. Here is my derivative. Here is my slopes of my tangent line at that, of this curve. What do I want to do? I want to find out where these slopes of my tangent line are horizontal. Horizontal line has a slope of 0. So let's take the slopes of my tangent line here, which is the derivative, right? And set that equal to 0 and solve. So what happens if I multiply both sides by the denominator here? I just get numerator is equal to 0, right? Now I can't factor that one, can I? If I could, it'd be nice. So I use my quadratic formula. That's just a quadratic equation I'm solving. So quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, right? You need to go back and review that. Go back and review it. Do a Google search, purplemath.com, Khan Academy, whatever. Do a search for quadratic formula, how to use. All right, so we have negative 6 plus or minus the square root. What is that? 36 minus what? 16 was 36 minus 16, 20 all over 2. So x will be negative 6 plus or minus 2 square roots of 5 over 2, or x is equal to, if I divide these by 2, let me actually do this. Let me actually say negative 6 over 2 plus or minus 2 square roots of 5 over 2. In other words, I put negative 6 over 2 and I put that part over 2. So that means that x is equal to what? Negative 3 plus or minus the square root of 5 is the values where my tangent line is horizontal. Now, for y, you're going to have to enter these in increasing order for it to give you credit. So you need -3 minus square root of 5 first, but then in your second blank, -3 plus the square root of 5. Got to put them in order for Wiley. And our last example here. Last example we have y is equal to x plus 5 over x plus 4. And it wants find out values of x in which the tangent line to the curve that is perpendicular to the line, y is equal to x. Okay. Let's recall what we learned about perpendicular lines in college algebra. This line right here has a slope of what? 1, right? There's an understood 1. It's in the form y is equal to mx plus b whenever it's written like this. So m is what? 1. The perpendicular line is going to have a slope of what? The reciprocal, which is still 1, but the opposite sign, which is negative. Remember, perpendicular lines have slopes that are opposite sides of reciprocals for the most part. All right, what do they want here? If we look at the directions, find out values of x in which the tangent line to the curve, this, is perpendicular to the line y is equal to x. So I want to find the tangent lines, or the slopes of the tangent lines of all these curves. Find out where that slope of my tangent line of all this curve, or the slope of the all the tangent lines to this curve is equal to that. What is the slope of the tangent line? The derivative, right? So let's find the derivative, y prime. Y prime is low, d high, minus I, d low, all over low squared. Remember, you're going to need to be able to write it fast like that because you're going to have a time test on this, or a time quiz, I should say. All right, so x plus 4. What's the derivative of this? 1. Well, you don't have to write it fast. You just got to know it right off the top of your head. You can't pause and then think. Minus x plus 5 times 1 over x plus 4 squared. So that means y prime is x plus 4 minus x minus 5 over x plus 4 squared. Well, these go away, right? So what I have, y prime is equal to -1 over x plus 4 squared. Now what is that? That's the derivative of this function, right? But isn't this also a formula for the slopes of all the tangent lines to this curve? Slopes of all the tangent lines. I want to know where the slopes of those tangent lines, or that derivative, is equal to -1. Let's multiply both sides by the denominator. -1 is equal to -x plus 4 squared. If I divide or multiply both sides by -1, 1 is equal to x plus 4 squared. Now, if we take the square root of both sides, we get plus or minus 1 is equal to, let me just go ahead and do this, the square root of x plus 4 squared. So that's plus or minus 1 because the square root of 1 is 1. It's equal to x plus 4. Solve for x. So we're going to subtract 4 from both sides. So we'll have -4 plus or minus 1 is equal to x. Now break it down into its two cases. -4 minus 1 is x. What's -4 minus 1? Well, that's -5, right? What's the other value? -4 plus 1. What's -4 plus 1? -3. That's where I have x values, where this curve has slopes of tangent lines that are perpendicular to that. Good luck with the homework.